Introducing a visual programming interface for beginners. The SEELAB device now combines the excitement of hands-on learning with the simplicity of drag-and-drop coding. Students can easily create and control electronic projects by connecting colorful blocks representing code elements. There's no complex syntax, just a playful environment that makes learning programming a joy and helps them in developing a fondness for problem solving. Now, with a focus on creativity and engagement, the visual interface makes learning to code a playful experience. Let's now move to a step-by-step tutorial on how to blink an LED with visual coding. In order to control the LED, we need to use one of the outputs of the SEELAB device. I've picked SQ1, which is a digital output, also capable of functioning as a square wave generator. This can be set to either 0 volts, which is a low state, or 5 volts. Now on the breadboard, I've connected a 560 ohm resistor, which is used to limit the current flowing through the LED. In series to the 560 ohm is the LED, and the longer leg of the LED is the positive, so that's connected to the resistor, and the shorter one is connected to ground, thereby completing the circuit. There are several ground pins, including those marked G and D. Now let's go and see if our circuit actually works. So we'll open the oscilloscope UI and use the SQ1 slider to set a frequency to it. Now we won't be able to see it blinking with such a high frequency, so let's adjust it and make it something more reasonable like 5 Hz. And now you can see that the LED does blink. Let's now exit the oscilloscope and enter visual coding. As you can see, there are a lot of sample programs already written, but for the purpose of this tutorial, we're just going to go and create a new program. At the top of this interface, you'll find buttons to execute your program, save it, restore it, and other options. And on the left, you have categories containing code segments that you wish to use. So we're going to pull out the set OD1 block, which is used to control digital outputs, and we're going to change OD1 to SQ1. Now if I execute this program, SQ1 will be set to on because that's the only instruction contained within this program, and you can see that the LED has lit up. But what we wish to do is to make things blink. So we're going to go to the loop section and pull out a wait block. So this essentially waits for 1 second. We've duplicated our first block and set the instruction to off, and we'll now wait another 1 second. So now when I run this, the LED turns on and then off. But we need this to happen continuously. So this is where we bring in loops. So in the loop section, we're going to pull out the repeat while true block, which basically repeats anything contained inside it as long as the condition is true. And we're going to drag our entire program so far inside the loop and run this loop. Now you can observe that SQ1 is being set to an on state, and then it waits for a second and then turns it off, then waits another second and keeps repeating this. Now that our program is complete, we may wish to share it. Before that, we click the Help tab, and the Instructions button allows us to add some documentation regarding this experiment. So here you can tell people what connections to make and what the program does, etc. And from the menu on the right, you can change whatever file name that you want and share it. So when you click the share button, it will ask you whether you want to share via email or WhatsApp or other options that are available on your phone. Now, let's try something different. I've connected the waveform generator to the A1 voltmeter input using a simple wire. We don't need any ground connections because both instruments already share the same ground internally. If, however, you were using two different instruments, you would have to connect a wire from ground of one to the ground plane of another. Now we go to the oscilloscope and we check that things are indeed working. So you can see that A1 is recording a sine wave, and if I change the frequency of the waveform generator, the sine wave frequency displayed also changes. Now coming to visual coding, how do we make an oscilloscope? So again, we need a repeat while true condition, and we're going to go to the capture section and select capture 1. So capture 1 is a single channel capture block where you can specify the number of voltage readings that you want to take, as well as the time gap between each reading in microsecond units. So since we're taking 1000 voltage readings with 5 microseconds between each, that's 5 millisecond total. Now the acquired data is stored into variables called timestamps, which is the x-axis, and data1, which is voltage readings along the y-axis. Now in the plot section, I'm going to pick out plot array x versus array y, where y is the voltage readings and x-axis is the timestamps. Both these will be found in the variable section. Now I'm going to add a small delay of, let's say, 0.1 seconds after each capture and plot, and just save this program so I don't lose it. And now I can execute this. So you can see that the sine wave is shown on the screen with an amplitude of around plus minus 3 volts, and this is being updated continuously. So if I pull out this wire, you can see that the amplitude goes down to a couple of millivolts, which is basically just noise. And if I plug it back again, you can see that the signal is shown again. Now what if I want to change this frequency while the program is running? So here you can go to the sliders section and pick out the frequency slider. We introduce this block before the loop starts, and this essentially creates a slider that has direct access to your waveform generator. You can see the results, and that's it for this video.